I guess this is why, that's sort of the reason I came up with this talk originally. And the sort of the subtitle that I gave it was SELinux, Don't Be Afraid. And the reason for that, I think, is because there's a lot of people have this impression that SELinux is a really fiendishly complex thing to understand and get to work with. It's developed by the NSA, you know, the no such agency. It's mandatory access control. It's going to force you to do stuff. It's got buzzwords coming out of its ears, and it's all hard to understand. And the worst part about it is, of course, everyone knows it breaks stuff. And this quote, I think, illustrates the whole problem nicely. This is, people probably know Ted So. He's the maintainer for X2, X3, and X4, the file systems. And you'd think if he can't get it working, then no one can. As a couple of little side notes here, I'll point out he uses Debian, and that actually has that relates to something later. He's also not what you'd call an everyday user. He's writing file system code from scratch. He's putting things into the kernel. He's doing a bunch of stuff that you're just not supposed to do as an everyday user. So that's a Ted's workload is not something that SELinux is really designed to protect from.
The guy that has an unclassified sticker on his laptop to stop the guys from M16 confiscating it.
This is true. He's apparently got an unclassified sticker on his laptop just in case. So the title of the talk is Don't Be Afraid, and I think this quote actually, for me, sums up why SELinux is a good thing to use. And if you think about it, it's pretty incredible that we have got someone as big and as you know, well versed in the security field as the NSA coming over and saying, here you go, not only here's a whole security framework, here's all the source code, and we're going to maintain it for you, and here's all the documentation as well. It's actually pretty amazing when you think about it. So, and Larry is a security author and researcher, so I hope he knows what he's talking about. So a quick history of SELinux. It's used in many major distributions. It was first put into the kernel, first written in 2000. It went into the kernel in 2002. Fedora put it in 2004, and followed by Red Hat. And then Debian and Ubuntu got it. And you can see if Ted was talking in 2007, he was probably using the first early versions of the policies in Debian. And that's actually something that's fairly critical. The policies that you get with SELinux are being refined over time, and now they are much less intrusive, even from what I've been using, than they were before. So how does it actually work? This is sort of a very simple description. It's basically compiled into the kernel, and you've got a bunch of basically a policy document that is packaged up either in an RPM or a deb file and loaded into that module. That then looks at all of the system calls and determines from those from that basically whether you're allowed to do that particular system call or not. What does it really do? That's the curse of SELinux talks, is getting bogged down in all of the jargon. So I'm trying to keep this relatively jargon free. What it does is stops daemons going bad. The policy that is written for SELinux, most people get, which is the policy, the targeted policy, basically just works on system daemons. It doesn't constrain the user at all. So root can still, where are we? Yeah, user processor. So root can still run everything as root and start daemons that it shouldn't normally be able to start and run things that shouldn't normally run under SELinux. And of course, Firefox can also break. Yeah.
I had it when I was using a Debian, I think it was just an etch that I couldn't actually play a video file because it was blocking the access to libav something.
Yeah, yeah.
So is that because of the sort of policies now been refined and changed so that doesn't happen?
So the question was, or the statement was, we had problems playing a video file because it was trying to load the AV library. And the complication there is that there's some of the libraries that do, especially video playing, do a thing called text relocation, which is also possible to exploit with a buffer overrun. And there's a SELinux policy which says this is I recognize this as a shared library that is going to do text relocation, and if it does text relocation, it's okay. And that policy has, I've seen in the recent rules, there are a whole bunch of libav codecs and that sort of stuff marked as textrel shalid-t, and so running if you've got the correct type on those libraries, then it should work. Now there are also ways to correct that for a library that you know is okay and it's causing problems now. So yeah, that's the kind of problem that people have with SELinux. There's something going on and it's blocked and you don't really know how or why, but finding out why and finding out what to do about it actually helps you go on from there. So new policy is being written to help all of those sort of things. So a quick bit of jargon, because it's really important to know this. Everything on your Linux system in SELinux has a context. And an important point, everything only has one context. You can't have more than one context on one thing. So files have contexts, processes have context, and then you've got a database of rules that says what one process can do to, a process in one context can do to a file in another context. So how do you see it happening? You have, most of the commands now have a -Z option, and that will show you, here's an example from my computer, and you can see, as well as the usual sort of description, we have a statement there which is the security context, the label that it's applied to, and that all looks really unusually complex to decode, but the thing that you really need to know is just the type, and that is, it's a word ending in _t. So directories in my home directory have the user home type. Processes, Firefox and Rhythmbox, because they're running as me, as the unconfined user, they're in the unconfined type. And likewise Bash and PS are in unconfined. So how do you actually get around using it? And this is the sort of thing that will solve exactly your problem. And it's, yes, this is the beginner's talk. If you may be bored, and this is why I hope you'll come to the sysadmin's talk, because this tool is fairly basic. It's restorecon. And what restorecon does is restore the SELinux context that's in the database onto the file that exists now. And this is actually the other really good reason for knowing about this command is if you've decided to turn SELinux off as opposed to putting it in permissive mode, what you've done is every file in your operating system now has no security context. And in that situation, Linux will say, SELinux will say, no, you're not touching that file. What you need to do is put SELinux in permissive mode in that situation and then run restorecon. So As an example of this, I've set this up on the slides because I don't trust myself doing live demos. If you look at the etc group file, it has the etc t. That's a fairly standard type for all files in etc. If we then copy it over to temp, when you copy something, you copy its security context as well. Sorry, no, wrong way around. When you copy it, you're creating a new file. And because of that, the new file is going to get the context of the directory that it's being created in. So at that point, at the copy, the file in temp group, so the temp group will have the user temp type. I move it back and that moves the context with it. This is another really good way of doing strange and terrible things to SELinux permissions. And as you can see, I've overwritten my etc group file with a thing called that's in user temp type. Yeah.
What about links? So if you link that file to temp, what actually happens? What's the permission on that then?
The permission. So the question is, what's the permission on a symbolic link or a hard link? And that is the permission on the underlying file. I don't know how. I think it copes differently with hard links, but certainly with symbolic links. The symbolic link, the context of the symbolic link isn't relevant because it's only when you finally get to open the file that it looks at the security context. So at this point, a couple of things went wrong in my system, and I said, I better put it back. So I simply do restore con -R for recursive. I don't need to be recursive to change one file, but that's a habit of my fingers now. And you can see it restore -V to tell me what's happening, and you can see restore con reset the group context back to etc t as it should be. That looked up the policy out of the database and said group files and etc get the etc type, and there you are. Now it has etc type. That's basically the first thing to do if you're having problems with SELinux is try restore con on the files that you're having problems with, because you may have either moved them around or not got the correct context, and that will have put them back. And that's just a good first thing to do to say, oh, okay, I know I'm at least dealing with the correct thing. So you've got this database of rules. We've also got switches that turn large chunks of rules on and off. And of course, if we're talking about switches, we're talking about booleans. So of course, to find these out, we have getCbool. So get the SELinux boolean, and then -A says, give me all of them. So if I feed that through grep, look for Samba, you can see there's a whole bunch of booleans that control ways that Samba operates in your system that you want to control with SELinux. So if you're not running a domain controller, you can say Samba domain controller off, and at that point it's not allowed to talk to read or write from a bunch of files that you might want to either keep locked down for some other reason, or just because limiting the number of information leaks or vulnerabilities is a good security policy. But you can also see we've got something called use Samba home DIRs off, and that setting, if I wanted to turn that on, I'd say setCbool Samba enable home DIRs on, and then getCbool, you can see it's turned on. Samba enable home DIRs, and I'll cover this more in depth in the sysadmins talk, but Samba enable home DIRs basically allows you to share your home directory. I'm going to get this the wrong way around, aren't I? It allows you to share your home directory as a Samba mount. There's also I think the other one, use Samba home DIRs. Yeah, use Samba home DIRs allows you to have a Samba mount as your home directory. Those sort of things are locked down in SELinux because you may not want Samba sharing files in your home directory in certain security situations. The problem with that is that that's actually only going to affect this session, and when I next reboot, that's going to be off again, and I'm going to be confused and rather annoyed that it's gone back to the way I thought I'd fixed. So you say -P, setcbool -P, and that actually updates the database to say this is now permanently on. And that actually will take about, depending on your system, 3 or 4 seconds, because it actually recompiles the binary description of the rule set with or without those rules in place. So it's actually trying to, instead of rereading the file every time you have to do something in SELinux, it actually keeps a binary copy in the memory. So tip 2, try use setcbool and getcbool to turn on features rather than either trying to move things around to be in the location that the daemon can access, or writing new policy. The booleans are probably going to do at least what you want as a beginner, as a new person to Linux. Now, how you see what's going on, and you can see, you use -Z to find out what the permissions are and what context I'm in, but if you want to find out what's just happened, you look in the audit log. Some messages are also going to go to varlog messages, but audit log is generally the place to check for SELinux messages. So when I changed the etc group file around, it held through an exception, and I looked in the audit log and I got this, which is mostly incomprehensible. There's a lot of stuff there, and it's all for people who are either writing haldi or writing SELinux policy, and for the most part, as a beginner, you just don't want to have to deal with that. Fortunately, there's a really useful tool called audit to Y, and that will take that message. So we're looking for haldi mentioned in audit log, and it will tell us why that particular thing failed. You can see haldi in the haldi type was trying to access something in the user temp type, and that's not allowed by the current policy. The complication here is, and the reason I'm not going to talk about audit to Y, audit to allow a lot in this talk, is because the assumption that's going on in audit to Y here is the permissions are correct, the contexts on the files are correct, it must be the database of rules that's wrong, and sometimes that's actually not true. I mean, I just added my etc group context, so changing the permission, I could feed that through audit to allow, and that would generate a new piece of policy that would say haldi is now allowed to talk to read anything of user temp type, which would give it access to my entire temp directory, and that may not be a good thing. So as far as audit to Y and audit to allow goes, my recommendation is keep them in mind just to find out what's going on, but don't try to use them in force. And I made this mistake. Don't try to really generate a lot of new policy unless you're actually debugging that service, if you're writing that service. If you're just trying to work out why something has failed, then there's probably a simpler reason in SELinux, and it's something as simple as restore con on your media libraries. The other thing you can do, which I foolishly haven't mentioned in this talk, but that's actually a good example. As well as restore con, you have chcon, like chmod or chown. Chcon changes the security context. So back in my command, it's too far. Back when I wrote this slide up, the slide for changing the permissions on etc group, I had chcon -t user temp type, on etc. group. So that just changed it in place. If you're dealing with, say, a library that's using text relocation as a shared library, and you want to say this is actually allowed to do it, and I've recently found that the accursed VMware, now VMware with version 2 now has a browser plugin, because everything is done in the browsers these days, I suppose. Instead of having an actual program that displayed it for you, you've got this browser plugin, and it does text relocation. But of course, it's not covered in the database because they're still trying to work out what VMware 1 is, Linuxy. So you have to go in manually and check on that file. You find it listed in the audit log, and you go, I remember that textrel shalib t. Apply it to that file, and that will allow you to load it. There's about 3 files that you have to change in VMware to type textrel shalib t to get that working. There's much more to SELinux, and I cover some of that in the sysadmin's talk, but I'm trying to keep this as a very general, simple thing, and I hope this hasn't been too trivial for you. Are there any questions, or has this been too easy? Yep, too easy. Oh well. Okay. Thank you very much. Yeah.
Example, Vimo going bad. What do you your experience or? Patching getting hammered, that it takes down the system, or?
Primarily, I haven't actually seen SELinux myself protect against something like this, but there were recently a number of Apache buffer overruns where the SELinux policy for Apache prevented that going any further. And that's the fundamental approach to a lot of this is, firstly, you don't want to... The 2 things we're really protecting against as far as the daemons go are the first situation is a buffer overrun or a hidden exploit or something like that being used to subvert the daemon to get it to do bad stuff. The other is someone putting a binary on your system which tries to do something which it's not allowed to do. So if someone managed to find your FTP daemon and put a rootkit on it and then use a buffer overrun to execute that, SELinux will also prevent that. A bit that I glossed over in the process, and it's worth talking about with Apache and other things like that, because one of the key attacks on Apache is CGI scripts. And a friend of mine was saying, I've got this, that'll be the wake, and it's going to take a minute to wake up now, but anyway. He had a server where he had to allow people to use a piece of CGI that would write a file and directory, and the same script to launch other programs, and he was able to launch other programs, and he wanted to make sure. Sorry, no, wrong way around. The script, the CGI script, was able to run other programs based on the user selection, and the people who are authoring the CGI script were out of his control. So he wanted to say, how can I prevent them from dropping a binary on my server that does nasty things? When when Apache starts up, it starts up from initd, and initd runs in the initd type. There's a rule in the SELinux database which says initd is allowed to run programs that change into Apache. This particular script, when it's run by initd, it changes into the HTTPD type. Things inside HTTPD type then get a much limited ability to run other programs. So they then, the only thing that they can run as a CGI script has to be has to have the type and you can tell I've had to do this. The HTTPD sysscript exec_t. If that file doesn't have that, then it won't be run by the CGI engine in Apache. But any file that the file server writes can't be written as HTTP sysscript exec_t. They can only be of HTTP sysscript read-write type. So that's your whole way of locking down those users in a predefined policy which is distributed everywhere. Does that making sense?
Yeah, so you're locking it down so unknown scripts can't execute.
Yeah. Unknown scripts can't execute, vulnerabilities can't be exploited, and in general, and the other reason for not running audit to allow just randomly to fix problems, the example I gave with the trying to fix up why HALD couldn't read etc. group file. If we said, okay, allow that, that was actually allowing HALD to read from any user temp type. And if there's something you don't know about that's badly written in HALD, then you find out the hard way that it shouldn't have been reading that. One of another thing that I've read on this topic is basically when you're writing SELinux policy, you say, well, should this daemon be reading the password file at all? Does it need to? Is there a better way that it could be doing this? You don't write the policy with the view of run the program and just take whatever it's been doing as granted, as an acceptable thing. You then review that and say, you know, maybe it shouldn't be opening that network socket out to, you know, cracker.org or something like that. Any other questions? Yes?
Do you run strict policy on your laptop?
No, I only run targeted. I don't run, the question was, do I run strict policy on my laptop? There is an interesting new policy that's being worked on, and I can't remember the name of it, but it basically, sorry? Sandbox, thank you. Yeah, you know, you know what you're talking about. It basically extends the policy from just covering daemons out to covering a whole range of other programs. So checking that grep doesn't open up a port to somewhere, or PS doesn't use naughty syscalls or something like that. So that if someone drops a rootkit on your system, SELinux will still lock it down, even though they're operating as an unconfined user. So this is actually pretty interesting as a development, and I think that a lot of the kind of policy that I'm looking for says Firefox is locked down. It doesn't get to read, you know, Samba mounts or unnecessary files in the proc directory, that sort of stuff. Making sense? Yes?
So what do you want to do? Stack up your remote files or something?
Yep. So where's the metadata stored? It's stored in extended attributes in the file system. So any system that's running SELinux enabled will have extended attributes on the file system turned on. If you're doing a backup, back up the extended attributes as well. The best tool that I've found for doing this is DAR, if you're familiar with that. DAR, as in disk archiver. It backs up extended contexts, so the SELinux and other extended attributes. It does a heap of stuff. It's really good. So there was another, sorry. rsync, does rsync support extended attributes? From memory, yes. The other key thing to remember here is when you're doing copy, which would also be when you're doing an rsync, as in when you're creating a new file, the new file is going to be given the policy that applies to that section of the directory in the rule set. So if you're doing, say, a backup, if you're restoring, as you copy the security contexts back, so as you copy the files back, even if you're not copying the security contexts, if you're restoring into the original place of those files, the target system will go, oh, okay, I know how to label those files because they're going in the correct directory. If you're doing a backup, a restore where you copy into a temporary directory and then copy them out from there, you would do a copy rather than a move. Again, you'd be restoring the extended attributes. But it is a good question. I'm not entirely sure how rsync handles that. Does anyone else know? No? Okay. There was another question. Yes?
I was just wondering what the relationship between SELinux and AppArmor is, if any?
Tense. What's the relationship between SELinux and AppArmor? They're both toolkits for restricting applications, and restricting daemons is the common use of them. They both work on a fairly fine-grained level of control. And they both work by having a part of the kernel that enforces that access. My understanding is that AppArmor is more written from the point of view of compiling it into the application, so that your application has, it's like the database of rules being built into the application and then being checked by the kernel. So if you don't have a rule that says you can specifically allow it, then you deny it. That's, I have to admit, I'm mostly ignorant about AppArmor, so I'm not entirely sure, but that's my limited understanding of it. Does anyone here use AppArmor? Yes? No?
It's also file-based rather than interactive.
Okay, so it uses a separate file to...
It uses file paths. So rather than...
Ah, I see. So the absolute location of that file determines what its context, if you like, is, rather than the extended attribute on that file. Okay, I'm with you. Which does solve that backup restore problem where if you copy a bunch of files into, as soon as you copy them into the right location, they are automatically in the right context. My understanding of AppArmor is that the policy isn't written, it's sort of, AppArmor controls what the application does, whereas SELinux is designed to say only these particular things can access that file. There's a whole level of complexity in SELinux with security classifications that we all never use because we're not in the military. I'm sure they use it at the NSA, and that's something, as far as I understand, AppArmor doesn't provide. So, Yeah. There was another question around somewhere, but I've forgotten where it was. Yes.
What's to stop like a malicious script creating a binary in a different context and then running?
In order to, so the question was, what's to stop a malicious script creating its own, the correct context to allow itself to run? The permission to change the security context on an object is itself restricted. So chcon and restorecon have a specific context which says these programs are allowed to change SELinux context.
If it's a new file, and then it inherits the context.
True, but in that case, getting a rogue application to then execute it is going to be difficult because it's in an arbitrary place. And I guess from the point of view of actually trying so firstly trying to write that file, you're going to have to manipulate some extended attribute, which is going to be tricky at best anyway. To get that to happen at all, you need to convince Samba or HTTPD to execute your script, which is going to be tricky because of the way that those permissions are set up. And then you need to get something else to, you couldn't use that to overwrite the password file because the password file has a context which protects it. So it's those are the kinds of questions where you sit down, as you sit down and answer them, your understanding deepens, but until you really have to think about it, you don't realise there's that level of complexity built in. And I suppose where I'm coming from with this talk was to say, SELinux is actually, I've been running it since Fedora Core 4, and I just haven't even bothered to turn it off. It's never got in my way enough, and by doing that, I've learned how to live with it, and those are my tips for passing it on. So, right.
That's quite a compliment, actually. To SELinux, like if it's one of those things where you turn it on and you more or less not have to fight it, that's as good as attestation to its value as any.
It's a very good. It's good on several fronts, as Andrew says. Firstly, that the policy is flexible enough to control all of the different ways that you might find around it. Secondly, that the package of policy that we get still allows us to get around in Linux and do all of the stuff, all of the crazy stuff that root wants to do, and run the kinds of things that we want to run without having to register an application with the NSA or something like that. And then, the fact that it just, it's still out there protecting people, even though for the most part we never cross tracks with it. So, yeah, it's a good point.